This is the ROS Developers Podcast, episode 48.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo Tellez from the Construct here. Hello, everyone. And today I would like to dedicate the podcast to the ROS developers that are developing using C++. Really, guys, you deserve the full day of the year dedicated to you. And I mean that because C++ development in ROS is so much difficult than developing, for example, with Python, especially if you want to build complex systems with many nodes, all of them working together, etc. So the bad news is that you still don't have a day of the year, but at least you have one podcast episode dedicated to you. So it's this one, guys. Now let's go with the interview of today. And today it is my pleasure to introduce you with Phillip J. Reed from SWRI. Phillip works at SWRI as a developer. And there he has developed a bunch of very useful tools for different situations on ROS that we are going to preview today here. They are like apps, small apps that are going to help us develop faster and better in our system. So welcome to the podcast, Phillip.
Thank you. It's good to be here.
My pleasure here. So before I start, let me tell you how did I meet your work. It's because there was an intern at the Construct. Actually, he's an Indian guy who is doing some work at our company, and he was suggesting us to use your tool that it's called MapBiz. Then I had no idea what is that, and maybe many of the listeners didn't know neither what is that. And then I started researching and said, "Wow, that's super cool tool." And then
great. I'm glad you like it.
Yes. So, but for the listeners, wait a second. We are still not going to talk about that in a minute, in some minutes. Okay, so let's go. So, Phillip, can you tell us what is the SWRI organization?
Oh, sure. So SWRI, or SWRI as we call it, is the Southwest Research Institute. Okay. It's a nonprofit research organization located in San Antonio, Texas. And we basically do research for hire for commercial and government clients. And SWRI has been in business since 1947, so we've been around for a long time.
Wow.
And we have several different technical divisions that do work in all kinds of different areas. So we have guys who do like ballistics testing or space research or signals intelligence and chemistry and many other areas. And I've been working at Southwest Research Institute for about 14 years now.
Wow.
I started, so it's been quite a while, but I like it a lot. I'm a senior research analyst now, which basically means I'm pretty high up in the software development chain. But I started out working here in the Defense Information Systems division, which does signal intelligence. And after about 10 years, I learned that there was a group here that was doing work on robotic vehicles, and I thought that sounded really cool. So I decided to switch to the Applied Sensing department, which is where I am now.
Oh, nice.
And we do research on unmanned ground vehicles, so cars, trucks, tractors. We also have a smaller group that's doing work on unmanned aerial systems as well. So we're interested in robots and how they perceive the world around them and how they navigate through the world.
But are you based developing? So your main goal is to develop the robots or the software? Are you using third-party robots for your projects? How does it work?
So we do both, actually. We do both hardware and software development.
Oh, okay.
Usually when a client comes to us, they have a specific need met by any off-the-market solution. Like I mentioned, we do research and development, so none of this is just an off-the-shelf robot that you can deploy somewhere. It's always a custom one-of-a-kind robot that's designed for a specific situation that's never been done before.
No, I see.
And so we have both mechanical engineers and electrical engineers and computer scientists who develop the hardware and the software to work together to create these robots for specialized situations.
And you specifically, what is the main part of your job at SRWI? Did I pronounce it correctly? SRWI.
Right. So I'm, like I said, a senior research analyst. And so what I do is a lot of the system architecture type work. I specialize in software. I've got a computer science background. And so I design the software architecture that we're going to use and figure out how we can run software on the hardware that we have. And I also help all of the younger developers figure out how to work together. So I'm in charge of a lot of the integration tasks. I handle our source code management and version control and continuous integration and testing.
Right.
And also something that I like to do a lot personally is tool development. I really like making software tools that other developers can use to make their jobs easier.
Ah, yes, the tools that we are going to talk today here. And the tools, the ones that I have seen at least, they are based on ROS. So all your development is based on ROS? So all the architectures that you are developing are based on ROS?
Right. It's I won't say we exclusively use ROS. We've used other frameworks too when we have clients that have different needs. But we like ROS a lot, and whenever we have the choice, we use ROS for everything.
Okay, yes, makes sense, of course. We all love ROS. Okay, and then about your repo. So you have a SRWI Robotics, you have a Git repo, which contains many different tools for working with ROS. So we are going to talk about them in some minutes, but I would like to know, how is the process in which you decide to build one of those tools?
So a lot of these tools are things that we developed because there was a gap where we needed a tool and there wasn't an existing one. And eventually, after thinking about it for a while, we get together and design these tools and develop them. And they're intended primarily to suit our needs and help us do a better job of developing robots. But pretty frequently, these aren't things that we're selling directly to customers, since our clients are interested in the robots and the software that run on them. They don't care about developer tools. And so after we make these tools, since we're not planning to actually make any money off of them anyway, we figure why not release them to the open source community, because that helps everybody else and it makes ROS better.
Okay. So then it's like you are creating those tools while you are developing the solutions for your customers, and then at the end you say, okay, what can we do with this, because it's already so cool feature, and then the ROS community can benefit from that, and then you publish there. Okay, that's
so cool. All of the tools that we make are things that we use internally for our own development.
Exactly. So you are not thinking about a tool, what could be cool for, and then you design that tool. Instead is, I need this thing for my work, then I develop, and then afterwards I release. Okay.
Right.
Great. And then let's talk about some of the tools that you have there.
Sure.
So you have one that is called SRWI Profiler. So this tool, what is its purpose?
So this is intended to be a lightweight, easy-to-use profiling tool for ROS nodes.
What's the profiling tool?
So what this is good at doing is it's used to tell you how long your program takes to run.
Okay.
So pretty frequently, what you want to know is how long does my ROS publisher or my ROS subscriber take to run every time it gets data. That way you can know where the hot spots in your program are, or where you need to optimize to make things faster. Or if things are running slow, it can help you figure out where the bottleneck is.
I see.
And there are a lot of existing profiling tools out there that are really good, like Valgrind, for example, is an open source one that we use. But a lot of the existing tools are frequently pretty hard to use. There's a big manual you have to read through, and you frequently have to compile your program in a certain way or with debugging symbols on, or you have to run it with special instructions. And so we thought that there was a need for a really simple, easy to use tool that could just give you a rough estimate of how efficient your program is. These other tools are useful if you need like microsecond level timing on things, but frequently that's not what we need. We need to know, is there a publisher somewhere that's taking 5 seconds to run? Or is this one publisher over here taking 5 times as long as a different one?
Okay.
And so what SWRI Profiler is if you want to use it, it's just a macro that you call in one of your functions. And when you call this macro, when the compiler compiles your code, under the hood, what it does is it creates 2 timers, one that tracks when the function starts and then one that tracks when it ends. And at the end of your function, it publishes a message indicating how long that function took to run. So this is also integrated pretty closely with ROS because it's using a ROS publisher to make this information available.
Okay, so it's publishing on a ROS topic, the result. So you can be there listening and get the result directly on real time. In real time, I mean.
Yeah, so all you have to do is add this macro into a function, and now there's a ROS topic that you can listen to see how long the function is taking.
Great. But you also have a web browser also that you can monitor. How is it?
Right. It's a pretty simple web application. It's just a web page you open up that uses the ROS web tools to subscribe to the topics where all of your publishers are publishing their timing information. And then it makes a graph that shows how long all of your profiled functions take to run.
Wow.
So you can see in real time how long each of them are taking to run compared to all of the others.
Wow, that's super cool. That's super cool. And
yeah, it's really useful.
It's very useful, exactly, to detect the bottlenecks, as you mentioned. And this is working with C++. So
right, this is all in C++.
Only in C++. Okay, so listeners, I will put a link to all those tools that we are going to talk today here. So don't worry, you will see the links to those tools on the show notes beneath this podcast. Okay, then the other tool that I wanted to talk about is the MapBiz, the one that I mentioned at the beginning of the interview.
Right.
So what is this MapBiz tool?
So MapViz is a top-down orthogonal visualization tool for robots.
Wow, what does it mean?
It's so if you're familiar with RViz, it's pretty similar to that.
Okay.
RViz is intended for a 3D environment where you've got a camera that you're rotating around your robot and looking at like a wireframe model or the environment around it. But MapViz always looks straight down at your robot from a satellite level.
Okay, I see.
So the reason we made this is because RViz is really useful for industrial robotics, for example, where you've got a robotic arm that's articulating in all kinds of different ways and you want to view it from different angles. But our group, like I mentioned, is working on ground vehicles. And for a car that's driving around a track, you don't really need to see it from every angle. You want to see top down so that you can see the car driving around the satellite imagery and see the road that it's following and look at the buildings and trees all around it.
Yes.
And you can do that with RViz, but it's a bit more difficult to do. When you're doing everything in 2D, a lot of the image calculations and operations get a lot simpler just because there's one less dimension to work with. And so that makes it a lot more straightforward to develop plugins for visualizing things that are overlaid on top of each other in 2-dimensional layers. So in MapViz, you can see your car that's moving around on top of satellite imagery at the same time that you're for example, visualizing a point cloud around it. So you can also see how the points overlay on top of the satellite imagery. And there are plugins for things like tracking GPS coordinates and odometry, so you can see the exact route that the vehicle followed. And we've got a pretty wide variety of plugins. I can't name them all off the top of my head, but there's also like an attitude indicator, so you can see what your IMU unit is doing. And of course, there's also things like image display plugins, so you can see what the cameras on your vehicle see in front of it. And you can also display the disparity if you have a depth camera or a depth image.
Okay, that sounds very, very interesting and very well oriented, for example, for autonomous cars. That would be, but also can be applied to any robot that has to move in known space with a map and path plannings and all that. And then, but then your tool has been developed from scratch, or is it based on RBase? You have taken the code of RBase and then modified, or like kind of cut some of the branches of RBase? I don't know, because it looked very familiar to me, like in RBase.
So it was developed entirely from scratch.
Wow.
There are parts of it that look similar to RViz, just because there are a lot of places where RViz's interface is pretty good, and we decided to just go ahead and copy it since it looks
use
good.
it, of course. Yes, makes sense.
But the underlying architecture is completely different. And it also has a really simple plugin-based architecture, so it's easy to write your own plugins that you can add to MatViz to visualize whatever topic or message type you need.
Okay, so that's very cool. I have seen it, and then I decided after this intern mentioned to us about this tool, then we decided to include also into our online development system that's called the ROS Development Studio. It's I don't know if you know it. It's an online platform for developing in ROS. So
I've heard of it.
Oh, okay. So then we decided to include it there. So then related to that is my next question is: all those tools are open source. Can we use them?
Yeah, definitely. Everything that we release should be licensed under the 3-clause BSD license. So we love it when people use them or contribute back if you have anything to add. But you're welcome to use it for all of your own projects.
Great. So I would let you know when we have already integrated there. Well, integrated, I mean, install it, because we have to install it. But I will let you know, because it's really cool. Please, people that you are there listening.
And of course, we love getting feedback about our tools also, since we develop and use them internally. A lot of times we aren't aware of the use cases that people outside SWRI have. So if there's anything that people have difficulty with or wish it would do differently, feel free to let us know so we can make it better. We might, just have never thought about it.
Okay, then I will do 2 things then based on that. First one, I'm going to ask the intern to provide you feedback, because he was using that for his own project. And second, I will put some homework to the listeners by the end of the podcast. So they have to try and then provide you feedback, okay?
Great, thank you.
Okay, so let's go with another tool that you have there that is called the SRWI Console. What is this about?
So this is a console utility for viewing the log output from ROS nodes. There's an existing console utility called ROS Console that you might be familiar with.
Yeah, exactly.
And a lot of people use it, and we used it for a little while, and honestly didn't like it a whole lot. The way the interface is designed isn't the way that we wanted to use it. And ROS Console works great for small systems, but when you have large systems that have a lot of messages going through it, it starts to have performance issues. So SWRI Console was designed to be a very performant logging tool that also made it easy to view and filter log messages in the way that we wanted to use them. So SRWI Console, like I said, it's designed to be really fast, so it can easily handle thousands of log messages per second without slowing down. And I've left it running overnight on my computer before, and in the morning had millions of log messages stored up. So really the only limit on its performance is how much memory you have. But it's also great at doing things like filtering log messages by the log level. So like if you want to turn off all of the debug and info messages, there's just a single button you can do that. You can also easily customize the logging level for individual nodes. Normally on a running ROS system, if you want to change the log levels for nodes, there are service calls you have to make. And there's a standalone RQT utility you can use to do that. But we thought it would be really handy to have that integrated into the console. So for any node that's in ROS, or any node that you can see in SWRI Console, you can just right-click on it to change the logging levels for that node. It can also do things like save the log messages to bag files. So you can have a bag file with all of your logs in it that you can replay later. Or you can load an existing bag file to get all of the messages out of it and display them in the console.
Okay, so it sounds great. It is true that the RQT console that we have, it's a little bit tough to configure. It requires many steps to get the output that you want. So then I haven't tried this one, the SRWI Console, but definitely I will give a try and give you some feedback.
Yeah, RQT Console, it's very configurable, but that also means that sometimes it takes a lot of work to configure it in exactly the way you want. But for our purposes, SWRI Console is just configured exactly the way we want it right out of the box.
Okay.
So it's very easy to use.
So so I didn't have the time to test it, this one, but definitely I'm going to test it also and give you some feedback about that, because it sounds very cool. So I buy. You know, you sold it to me, so I buy.
Great, thank you.
Okay, then another tool that we have in your repo, it's called Image Zero Transport.
Yep. So the image transport system in ROS, just in case you're not familiar with it, is a library that's designed for publishing and subscribing to camera topics.
Yep.
So if you have a camera, frequently you have nodes that want to just get raw image data off of the camera, but sometimes you want to get compressed data instead. And you might want to be compressed as a JPEG or PNG or even a movie format. And the image transport architecture is designed to make all of that easy to do. So you can create plugins that implement arbitrary compression formats, and then all of your publishers that are using image transport will automatically use that without needing to modify the program at all. Okay. So what Image Zero Transport is we ran into a problem on one of our systems where we had a vehicle that had 8 cameras on it that were all running over a single gigabit Ethernet link. Okay. And we just couldn't get the throughput that we wanted out of it because with all of the cameras running at their normal frame rate, it was just too much for a gigabit link to handle. Wow. And we wanted to come up with a way to compress that image data that was fast enough that we could do it in real time, and also got a good enough compression ratio we could do it over a gigabit link, and also was lossless because our image processing algorithms want to have the raw data. And so after spending a while searching around, I found a algorithm that somebody wrote on the KDE developers blog called Image Zero, which was designed to do fast lossless compression of color photography. So it only works on 3-channel color imagery. But what's great about this is that it's lossless. So it's similar to PNG, except it's about 20 times faster than PNG. Wow. So you can actually run it in real time without significant CPU overhead. And I took this and converted it into a ROS node and then made a image transport plugin for it. So if you install this package, now you can transparently transmit all of your image topics using Image Zero compression. So in practice, they take up about half as much bandwidth as raw images do, but it's fast enough to run in real time. Okay,
but how does it work? So I still don't understand how it actually works, your tool. So we have, for example, in the example that you mentioned about the cameras, then you have the 8 cameras, and those 8 cameras are connected to a computer.
Right.
Is that, and then you want to transmit these images from that computer to some other servers somewhere, and that's where the problem is. Yes, is that right? Then on this computer, you install your package, your Image Zero Transport packages, but then still you need to create a node that is using those libraries. Is it? So that's the part that I don't understand really. How should I implement it? Go.
The great thing about the image transport library is that there's actually nothing special your node needs to do. If you're already using ROS's image transport to publish your messages, if you look at the topic list, for example, you might have an image topic.
Yes.
And under that, you'll have like a image compressed topic,
yes.
And a image SWRI topic. Yeah. So image transport automatically makes all of these different topics for every transport plugin you have installed. So as soon as you install the Image Zero transport, it will automatically make a Image Zero compressed topic for every image you publish.
And also, then it will publish in all the topics depending on the plugins that you have installed. And those plugins, what they do is to allow different types of image formats. Is that correct? Okay.
Right.
Okay.
And then on the subscriber side, you can either subscribe directly to a compressed topic, or if you're using the image transport subscriber, there is a ROS parameter you can set to control what type of compression it uses. And so normally just using the default image transport plugins, you could set it to JPEG or PNG to use those compressions. But after you've installed image 0 transport, you can set the compression type to image 0. And it will automatically use the image 0 transport type.
Okay. I see. Now I see. So on the other side, you are going to read the messages that come from the main computer that have the cameras attached. You are going to read in image 0 message format. Okay. And then it will automatically uncompress and show you the image as the original camera.
Right. So you've got so from the perspective of your publisher and your subscriber, it's completely transparent. They don't need to know anything special. It'll just automatically compress the image as it goes between them.
Okay, cool. I think that we can also use this tool is in a project with a company that we have, and they want to provide remote access to their robots. And then they of course, the robots, they have cameras, but also the system has on top cameras. So you can see what is the robot actually doing, not only the cameras of the robot. So at the end, you get a lot of data, a lot of camera data that has to be transmitted to the customer side, from the real robot, because it's a remote lab accessing. Okay, so I think that could be a good place to use it.
Great.
Okay. Well, I think that I told you to put some homework to the listeners, but I think that I'm getting more homework in my side, I think.
Yeah, so the way image transport works under the hood is a little complex, but it's actually really simple from the subscriber and publisher perspective.
Yes. Okay. Yeah, I think I got it right now. Then we have the last tool that I would like to talk about here today. It's called Back Database. What is this tool for?
Back Database. So when we're testing our vehicles, we record ROS bag files that have all of the sensor measurements in them, so that we can play them back later to debug our vehicles and diagnose what happened, or to simulate vehicles in simulations. And a problem we eventually started running into is that we have a lot of bag files. We have probably about 50 terabytes of bag files that we've saved. And that's not all that we've recorded. That's basically just all the bag files we thought were interesting enough to keep. I'm sure that we've thrown away several times that much data.
Wow.
And so when you have that many bag files, it's really hard to keep track of all of them, because you want to know what vehicle they came from and what kind of sensor information they have in them and where they were recorded and like how long they are, or all that kind of stuff. And so I decided to write a tool to make it easier for us to catalog and search through all of our bag files, and that's what the Back Database is. And this was also kind of written because before I started working here, I had a background in enterprise Java development. So I had done a lot of work making web-based Java programs that use enterprise database backends. And I took that expertise and applied it here. So under the hood, it's running a Java enterprise program on top of a Postgres database. And basically the way it works is it's a Docker container that you start and you point it at a directory, and it will automatically read all of the bag files in there and parse them and store information about them in its database. And then it provides a web page that you can go to see a list of all bags, and it'll show you all of the information that it's extracted from them. And it also has a interface you can use to search for different information in the bag files. So if you want to search for specific topic names or specific message types, you can just put that into the search bar and it will show you all of the bag files that meet that criteria. And it has a few other pretty handy features built in, like for any bag files that have GPS coordinates stored in them, it will extract those and store them in the database. So there's a button you can click on to see a map that shows the path the vehicle followed. So if you search for bag files and you find 30 results and you don't know which one of them is the one you want, you can click on the map icon to actually see the path the vehicle followed.
Okay, so that's the one that we created last Friday. Then because you know where you were that last Friday.
Mm-hmm. Right. You can also view images or video topics in bag files. So if you open up the information for a bag file, if it has any camera image topics, you can look at the first image on that topic or even play back the topic as a video in your web browser. So you can see what the camera feed for the vehicle looked like when it was driving around.
Wow, amazing.
Mm-hmm.
So
it also...
Yeah, go ahead.
Another neat thing it does is it uses Google's reverse geocoding API to obtain friendly names for the locations where your vehicle was. So assuming your vehicle bag file has GPS coordinates in it, it will look up those GPS coordinates as a street address and be able to tell you, for example, this bag file was recorded at 6220 Culebra Road in San Antonio, Texas.
Wow.
And so in our database, we can also go in there and search for any bag files that were recorded at Culebra Road, and we'll find everything that was at our test track here.
Wow, it's amazing. That's very cool tool. That's a very cool tool. So it's basically is the Google for ROS bags, I would say.
Kind of, yeah.
It's the Google for ROS bags. That's amazing. And do you know of anybody that is using it with some public repo, or that is providing this as a service, so anybody can, for example, visit right now and check the database, or maybe yourselves?
I don't know of anyone who has a public bag database available. There are several other people and companies who have their own private ones running that are using it internally. And it's actually probably our most popular tool in the repository.
I can imagine.
It's gotten a lot of attention. And I wish I could spend more time developing it. Like I mentioned earlier, a lot of these tools are kind of developed as side effects of the projects that we work on for clients. So if we're not working on a project for a client, some of these tools don't get as much attention as the others. And I haven't been able to work a lot on the bag database recently, but I would like to more in the future.
Yeah. What about maybe, can I propose you an idea for the next year? Is a Google Summer of Code to get some interns, some people that will develop this under your direction, maybe? Yeah,
that could be really useful. And I do have a couple of ideas for things that I would think would be really useful. One is implementing some kind of authentication and authorization mechanism. Right now, I think the one thing that's stopping anybody from making a publicly available site is that there isn't any kind of authentication on it. If you go to the web page, you'll see everything that's there, and you can edit metadata in bag files and add tags to them. And that's great if you're working on an internal site and you trust everybody, but that's not something you want on the web. And I would like to add login and access protection mechanism so it's more suitable for that. But we internally don't need that, so I just haven't had the time to spend on it.
Yes, I understand.
And another thing that I would really like to do is add some post-processing features to it. Very frequently, what somebody would like to do after you recorded a bag file is extract a bunch of information out of it and use it for some task. Like, let's say you're training a neural network and you want to get all of the image data for a camera and run it through your neural network to either train the network or classify the data and test your network. And you would like to be able to do this automatically. So if you've got like 30 bag files, you want to be able to just drop them all in the bag database and have it automatically extract all of that and run it through your network and show you the outputs. And so the bag database can't currently do that, but I would love for it to be able to. I think it'd be great to be able to like add in just a little Python script that you could set it to run on every bag file it reads, so it could do whatever kind of analysis you want and then send you the results.
Yeah, okay. So now at present, you have to select which one bag and then provide this bag to your program of the neural network or whatever to extract the features. So you have to do all this process manually.
Yeah, and then the bag database, it does have a JSON-based API you can use. So you could write a Python program that would query the bag database and pull the bags you want. But that's still a more manual process than I'd like.
Okay. Wow, impressive. Impressive. Okay, so one more tool that I have into my homework. Okay, great. Thank you for giving me so much homework.
Yeah,
Thank
no
you.
problem.
Thank you. Okay, so then any other tool that I may have forgotten that I didn't catch in your repo that you would like to tell us about?
So one other repository I'll point out, which is just called MartyCommon. And this isn't a specific tool, but it's a collection of a whole bunch of different little libraries that we've developed for things that we needed. I will say that, unfortunately, MartyCommon isn't documented as well as some of the other stuff. The documentation on it is something I want to make better. But it has a lot of handy little libraries in here for doing ROS development. So for some examples of some of the things it can do, it has a serial console library. So if you're connecting to like a GPS device or a IMU over a serial connection, there's a C++ library to make that easy to do. So it's easy to read and write bytes directly to a device. Or a thing that you very frequently want to do on ground-based robotics is translate between global WGS84 latitude and longitude coordinates into a local ROS frame.
Yes.
And you can't do that with a normal ROS transform. But we've made our own transform class in the SWRI transform util package. And it provides a mechanism for transparently transforming between WGS84 coordinates and ROS frames.
Wow.
So you can treat latitude and longitude coordinates like any other ROS frame.
Wow.
And it can be a little bit complex to set up, but it works really well. And we use it on all of our vehicles. So for example, something you might want to do is record a route in WGS84 coordinates, so you know the exact latitude and longitude that your vehicle is moving through. But obviously in your ROS system, your actual ROS nodes want coordinates in local ROS frames.
Yes.
And so
frame.
our SRWI transform util is easy way to transform back and forth between those coordinate systems.
Yes, that we usually do this by using, for example, the transform nav from the robot localization package of ClearPath. So we use the transform nav package that provides you, so you have to feed with the GPS data, and then it will create a transform from that GPS into a map coordinate in ROS. And that's not, well, it's not difficult, but it's a pain to do that. And
yeah, it is a pain to set up.
To set up, exactly. And then in your case, but you mentioned that also in your case it's a little bit complex to set up. Did you mention that?
Yeah,
so what's the advantage?
It's just naturally mathematically complex to do because ROS frames are just flat coordinate planes in meters, and the ROS transform system doesn't handle any kind of scaling or shearing. Whereas WGS84 is a spherical coordinate system. And so you need some kind of system other than just the ROS TF mechanism to be able to transform between those two. Okay. And the way we do that is by publishing a special topic called LocalXY origin. And what this is it's a single GPS coordinate that indicates the latitude and longitude that corresponds to 0, 0 in your ROS map frame. So the first thing you have to do is you have to make sure that topic exists and is published appropriately. But after that exists, our SWRI transform class works just like the ROS TF, except it has a special frame called WGS84, and it can transform between WGS84 and ROS coordinates.
Okay, yes, more or less I do understand, but I cannot see very well the difference between the transform nav and this method. Do you have any web page that with documentation where we can check more about that and learn more about that? I would like to check also.
I would love to have that. Unfortunately, that's one of the things that isn't documented great right now.
Okay. Any example that you may have already working
if you want
in simulation?
Example, actually, MapViz actually uses this pretty extensively.
Okay.
So if you look at any of the MapViz Plus satellite data, like there's a map used to draw satellite images from tilemap servers like Bing or ArcGIS, and it uses the SWRI transform util to figure out how to coordinate those tilemaps with ROS frames.
Okay. Okay, yeah, I'm asking you about that because I was doing some live classes on the internet using the Transform app and showing how can, for example, one person can use a robot based on GPS coordinates to make a trajectory, you know, for example, in a field, an agricultural robot that wants to move on a field. And then I had to do all these transformations from the GPS to a local map, local coordinates, not a map because there was no map, but in the local coordinate systems, a kind of odometry. And then I was using the Transform app. Then I would like to see the difference and then maybe do another live class showing this other alternative because many people was asking me about that. They are worried, especially on the ROS agriculture field, people that this group is trying to make tractors and other agriculture machines that they want them to move around autonomously, doing all the farm tasks by themselves. You know, do you have any contact with those guys? ROS agriculture group?
So I personally don't. I know that we do have other people at SWRI who have worked with them.
Okay.
And actually, I should mention that I'm said earlier that I'm part of the Applied Sensing Department, and we do all unmanned ground vehicles. We have another pretty big group here called the Manufacturing and Robotics Technologies Department, and they focus very heavily on industrial robotics. So if you've heard of ROS-I or ROS Industrial, those guys work very heavily with that group. And in particular, Matt Robinson is a pretty well-known guy who is involved heavily in ROS Industrial, and he's a great guy to talk to if you're curious about any of that.
Okay. Matt Robinson. Yes, he is the one in charge of the ROS Industrial Consortium in America, actually, isn't it?
Right.
It's him.
That's right.
Okay. Yes. Okay. So a lot of information here. Then last question. So what is the future of those tools? So which ones are you preparing right now? You are working on that we can wait for them impatiently.
So like I mentioned, I do have a handful of ideas for back database development that I'd like to implement. Most of that is waiting on a client who actually needs that, so we have the time and money to work on it. But another thing that we're actually about to start ramping up on is ROS2 development. And we're just getting started on it, but we're beginning to look at using ROS2 for some of our projects. And we're going to dig into the ROS2 infrastructure and figure out what needs to be improved there and what needs to be added. And so in the near future, we're probably going to start working on converting some of our hardware drivers and applications to work on ROS2. So you'll probably see that in the near future.
Okay, so ROS2 versions of some of those tools, maybe. Okay.
Yeah, in particular, I think after we start doing development on real vehicles, MapViz is going to be really useful to have in ROS2. So that might be one of our first applications.
Okay, that's great. There is a high activity into the group of ROS2 related to translation the ROS navigation stack into ROS2. So maybe if you mention to them about this MapViz, can be also another tool incorporated there.
Yeah, that's true.
I don't know, just suggesting things. Or maybe some people in the ROS2 consortium that is listening this podcast, maybe can contact Philip for if it's interested. So I have already seen this previously. For example, there is this guy, that Davide Faconti, who has created some libraries for behavior trees that they are going to be integrated into the main part of ROS2 in substitution of the state machines, for example. And that happened like that.
He's actually contributed quite a bit to MapViz. So if you look through some of the David Faconti.
Oh, is it? Oh, you didn't know that.
So if you look through some of MapViz's plugins, you'll see code that he wrote in there.
Oh, okay. What a surprise. A small world. Okay, great. Great, great. So that's all here. Thank you very much, Philip, for all the information and all the tools.
Yeah,
that you're
thank you for your
developing.
time. I hope that you find them useful, and if there's anything you think they could do better, feel free to let us know.
Okay, so I can tell you. So we are going to start by including MapBiz in our development system and let you know when it's there. So
Great.
I mean, maybe it's useful in your side to provide hey, look at this is another professional tool that is using our plugin. So we are doing very good job in here. So I don't know. So I will let you know.
Great.
And so that's all. Well, one question: are you going to attend the ROSCon this year?
So I don't know for sure if I will or not. Probably not. Actually, we usually send a guy named Jerry Towler to ROSCon. I work pretty closely with Jerry, and he's a great guy. He's also done a lot of work on MapViz and SWRI Console. Unfortunately, we can't afford to send everybody to ROSCon.
Yes.
But Jerry loves to go, and he's a great guy, so you'll probably see him there.
Okay, so then I will look for him then. Okay. Thank you very much, Philip.
Yeah, thank you.
Cheers, bye. And
Bye.
For all the listeners, let me remind you that if you want to learn ROS, there is no more practical way than learning ROS at the Robot Ignite Academy. We have created the 30-70 teaching method, which is based on 30% of the time learning the theory and 70% of the time practicing with simulated robots. We provide a complete ROS environment and simulations already set up for you online. So you only need to have a web browser and any type of computer. And then you can start practicing how to program ROS robots from minute 1. Have a look. I will put a link beneath this podcast. And that is all for today, guys. See you the next week with a new lesson from the experts. And until then, remember to keep pushing your ROS learning.
The ROS Developers Podcast. The ROS Developers. The ROS Developers Podcast. The ROS